Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You need to set up a cloud interconnect connection between your company's on-premises data center and VPC host network. You want to make sure that on-premises applications can only access Google APIs over the cloud interconnect and not through the public internet. You are required to only use APIs that are supported by VPC Service Controls to mitigate against exfiltration risk to non-supported APIs. How should you configure the network? The options are: Option A, enable private Google access on the regional subnets and global dynamic routing mode. Option B, create a name to map star.googleapis.com to restricted.googleapis.com, and create a records for restricted.googleapis.com mapped to 199.36.153.8/30. Option C, use private.googleapis.com to access Google APIs using a set of IP addresses only routable from within Google Cloud, which are advertised as routes over the connection. Option D, use restricted.googleapis.com to access Google APIs using a set of IP addresses only routable from within Google Cloud, which are advertised as routes over the Cloud Interconnect connection.
To arrive at the correct answer, we focus on the keywords: Cloud Interconnect Connection. On-premises applications can only access Google APIs over the Cloud Interconnect, only use APIs that are supported by VPC Service Controls.
The correct answer is option D, use restricted.googleapis.com to access Google APIs using a set of IP addresses only routable from within Google Cloud, which are advertised as routes over the Cloud Interconnect connection.
Why is this correct? D. Restricted.googleapis.com restricts access exclusively to APIs supported by VPC Service Controls. Advertising its specific IP range over Cloud Interconnect enables private on-premises access while meeting all security requirements. Why are the others incorrect? A. Enabling private Google access on subnets only applies to VMs within the VPC. On-premises access requires configuring DNS and routing, and this option does not restrict access to VPC Service Controls APIs. B. The IP range 199.36.153.8/30 is associated with private.googleapis.com, not restricted.googleapis.com. This misconfiguration would allow access to APIs not supported by VPC Service Controls. C. Using private.googleapis.com grants access to most Google APIs, including those unsupported by VPC Service Controls. This violates the requirement to strictly mitigate exfiltration risk to non-supported APIs.
Your company must follow industry-specific regulations. Therefore, you need to enforce Customer-Managed Encryption Keys (CMEK) for all new cloud storage resources in the organization called Org1. What command should you execute? The options are: Option A, Organization Policy, constraints/gcp.restrict storage non-CMEK services binding at org1 policy type, allow policy value, all supported services. Option B, Organization Policy, constraints/gcp.restrict non-CMEK services binding at org1 policy type, deny policy value, storage.googleapis.com. Option C, Organization Policy, constraints/gcp.restrict storage non-CMEK services binding at org1 policy type, deny policy value, storage.googleapis.com. Option D, Organization Policy, constraints/gcp.restrict non-CMEK services binding at org1 policy type, allow policy value, storage.googleapis.com.
To arrive at the correct answer, we focus on the keywords: enforce Customer-Managed Encryption Keys (CMEK), cloud storage, org1.
The correct answer is option B, Organization Policy, constraints/gcp.restrict non-CMEC services binding at org1 policy type, denied policy value, storage.googleapis.com.
Why is this correct? B. Constraints/gcp.restrict non-CMEC services is the correct organization policy constraint. Denying storage.googleapis.com, and this constraint enforces CMEK by restricting non-CMEK resource creation for cloud storage across org1. Why are the others incorrect? A. The constraint constraints/gcp.restrict storage non-CMEK services does not exist. Additionally, and allow policy permits non-CMEK usage instead of enforcing CMEK. C. The organization policy constraint constraints/gcp.restrict storage non-CMEK services is invalid and does not exist in Google Cloud. D. Setting the policy type to allow for storage.googleapis.com explicitly permits non-CMEK resources, failing to enforce the CMEK requirement.
You are working with a client who plans to migrate their data to Google Cloud. You are responsible for recommending an encryption service to manage their encrypted keys. You have the following requirements. The master key must be rotated at least once every 45 days. Solution that stores the master key must be FIPS 140-2 Level 3 validated. Master key must be stored in multiple regions within the US for redundancy. Which solution meets these requirements? The options are: Option A, Customer-Managed Encryption Keys with Cloud Key Management Service. Option B, Customer-Managed Encryption Keys with Cloud HSM. Option C, Customer-Supplied Encryption Keys. Option D, Google-Managed Encryption Keys.
To arrive at the correct answer, we focus on the keywords: rotated at least once every 45 days, FIPS 140-2 Level 3 validated, multiple regions within the US.
The correct answer is option B, Customer-Managed Encryption Keys with Cloud HSM.
Why is this correct? B. Customer-Managed Encryption Keys with Cloud HSM provide a FIPS 140-2 Level 3 validated hardware-backed solution. It supports custom key rotation schedules, such as 45 days, and can be configured for multi-region redundancy. Why are the others incorrect? A. Standard software-backed Cloud KMS keys are only FIPS 140-2 Level 1 validated, which fails to meet the Level 3 validation requirement. C. With customer-supplied encryption keys, CSAK, you must manage key rotation and redundancy yourself outside of Google Cloud. Google does not store the master key. D. Google-managed encryption keys do not allow customers to enforce a custom 45-day rotation schedule, as they default to a 90-day rotation.
You have stored company-approved compute images in a single Google Cloud project that is used as an image repository. This project is protected with VPC Service Controls and exists in the perimeter along with other projects in your organization. This lets other projects deploy images from the image repository project. A team requires deploying a third-party disk image that is stored in an external Google Cloud organization. You need to grant read access to the disk image so that it can be deployed into the perimeter. What should you do? The options are: Option A, allow the external project by using the organizational policy, constraints/compute.trusted image projects. Option B, 1, update the perimeter. Point 2. Configure the egress to field to include the external Google Cloud project number as an allowed resource and the service name to compute.googleapis.com. Point 3. Configure the egress from field to set identity type to any_identity. Option C, 1, update the perimeter. Point 2. Configure the ingress from field to set identity type to any_identity. Point 3. Configure the ingress to field to include the external Google Cloud project number as an allowed resource and the service name to compute.googleapis.com. Option D, 1, update the perimeter. Point 2. Configure the egress to field to set identity type to any_identity. Point 3. Configure the egress from field to include the external Google Cloud project number as an allowed resource and the service name to compute.googleapis.com.
To arrive at the correct answer, we focus on the keywords VPC Service Controls, perimeter, deploying a third-party disk image, stored in an external Google Cloud organization, grant red access, deployed into the perimeter.
The correct answer is option B. 1. Update the perimeter. Point 2. Configure the egress to field to include the external Google Cloud project number as an allowed resource and the service name to compute.googleapis.com. Point 3. Configure the egress from field to set identity type to any _identity.
Why is this correct? B. An egress rule allows resources inside the VPC Service Controls perimeter to access the external disk image. The egress to field correctly targets the external project, and egress from allows any identity in the perimeter to initiate the request. Why are the others incorrect? A. The compute.trusted image projects constraint restricts which projects can provide images for compute instances but does not configure network access through VPC Service Controls. An egress rule is still required. C. Ingress rules manage API requests originating from outside the perimeter to resources inside. Accessing an external disk image from inside the perimeter requires an egress rule. D. The egress fields are reversed. The egress to field must define the target external resource, the project number, and the egress from field defines the identity initiating the request, any _identity.
You run applications on Cloud Run. You already enabled container analysis for vulnerability scanning. However, you are concerned about the lack of control on the applications that are deployed. You must ensure that only trusted container images are deployed on Cloud Run. What should you do? Choose 2. The options are: Option A, enable binary authorization on the existing Cloud Run service. Option B, set the organization policy constraints/run. Allowed binary authorization policies to the list or allowed binary authorization policy names. Option C, enable binary authorization on the existing Kubernetes cluster. Option D, use Cloud Run breakglass to deploy an image that meets the binary authorization policy by default. Option E, set the organization policy constraints/compute. Trusted image projects to the list of projects that contain the trusted container images.
To arrive at the correct answer, we focus on the keywords applications on Cloud Run, only trusted container images are deployed on Cloud Run.
The correct answers are option A, enable binary authorization on the existing Cloud Run service. And option B, set the organization policy constraints/run. Allowed binary authorization policies to the list or allowed binary authorization policy names.
Why is this correct? A. Enabling binary authorization on the Cloud Run service directly enforces policies that verify image signatures, ensuring only trusted container images can be deployed. B. Setting the run.allowed binary authorization policies organization policy constraint enforces the use of specific binary authorization policies for Cloud Run deployments across the organization. Why are the others incorrect? C. This option applies to Kubernetes clusters, like GKE, not Cloud Run, which is the specified deployment platform. D. Breakglass is an emergency bypass mechanism that allows deploying images that do not meet binary authorization policies, violating the core requirement. E. The compute.trusted image projects constraint is used for compute engine VM images, not for container images used in Cloud Run.
Your Google Cloud organization allows for administrative capabilities to be distributed to each team through provision of a Google Cloud project with owner roles/owner. The organization contains thousands of Google Cloud projects. Security Command Center Premium has surfaced multiple open_mysql_port findings. You are enforcing the guardrails and need to prevent these types of common misconfigurations. What should you do? The options are: Option A, create a hierarchical firewall policy configured at the organization to deny all connections from 0.0.0.0/0. Option B, create a hierarchical firewall policy configured at the organization to allow connections only from internal IP ranges. Option C, Create a Google Cloud Armor security policy to deny traffic from 0.0.0.0/0. Option D. Create a firewall rule for each virtual private cloud (VPC) to deny traffic from 0.0.0.0/0 with priority 0.
To arrive at the correct answer, we focus on the keywords: organization, thousands of Google Cloud projects, open_mysql_port. Prevent these types of common misconfigurations.
Correct answer is option B. Create a hierarchical firewall policy configured at the organization to allow connections only from internal IP ranges.
Why is this correct? B. A hierarchical firewall policy at the organization level enforces centralized rules that project owners cannot override. Allowing only internal IP ranges effectively prevents external exposure and mitigates the open_mysql_port findings across all projects. Why are the others incorrect? A. Denying all connections from 0.0.0.0/0 would block all external traffic, including legitimate public-facing services, like web servers, causing massive disruption. C. Cloud Armor is designed to protect HTTP/HTTPS applications behind external load balancers, not for enforcing network-level port restrictions like MySQL across all VPCs. D. Creating individual firewall rules per VPC across thousands of projects is administratively unscalable, and project owners could easily delete or modify these local rules.
The database administrator notices malicious activities within their Cloud SQL instance. The database administrator wants to monitor the API calls that read the configuration or metadata of resources. Which logs should the database administrator review? The options are: Option A, admin activity. Option B, system event. Option C, access transparency. Option D, data access.
To arrive at the correct answer, we focus on the keywords: monitor the API calls that read the configuration or metadata of resources.
Correct answer is option D, data access.
Why is this correct? D. Data access audit logs contain API calls that read the configuration or metadata of resources, as well as user-driven API calls that create, modify, or read user-provided resource data. Why are the others incorrect? A. Admin activity logs record API calls and administrative actions that modify the configuration or metadata of resources, not those that only read them. B. System event logs contain entries for Google Cloud automated actions that modify the configuration of resources, not user-driven API calls. C. Access transparency logs record actions taken by Google personnel when accessing your content, not API calls made by users or services within the environment.
Your organization has on-premises hosts that need to access Google Cloud APIs. You must enforce private connectivity between these hosts, minimize costs, and optimize for operational efficiency. What should you do? The options are: Option A, set up VPC peering between the hosts on premises and the VPC through the Internet. Option B, route all on-premises traffic to Google Cloud through an IPsec VPN tunnel to a VPC with private Google access enabled. Option C, enforce a security policy that mandates all applications to encrypt data with a Cloud Key Management Service (KMS) key before you send it over the network. Option D, route all on-premises traffic to Google Cloud through a dedicated or partner interconnect to a VPC with private Google access enabled.
To arrive at the correct answer, we focus on the keywords: on-premises hosts, access Google Cloud APIs, private connectivity, minimize costs, optimize for operational efficiency.
The correct answer is option B, route all on-premises traffic to Google Cloud through an IPsec VPN tunnel to a VPC with private Google access enabled.
Why is this correct? B. Cloud VPN provides a secure, private connection over the Internet at a lower cost than interconnect. Configuring private Google access for on-premises hosts allows access to Google APIs through this VPN tunnel, meeting all requirements efficiently. Why are the others incorrect? A. VPC peering is used to connect two VPC networks within Google Cloud, not an on-premises network to a VPC. Furthermore, peering cannot be established over the public internet. C. Application-level encryption using Cloud KMS does not fulfill the networking requirement to establish private connectivity between on-premises hosts and Google Cloud APIs. D. While Cloud Interconnect provides private connectivity and supports private Google access for on-premises hosts, it is significantly more expensive than Cloud VPN, failing the requirement to minimize costs.
As part of your organization's Zero Trust strategy, you use Identity-Aware Proxy (IAP) to protect multiple applications. You need to ingest logs into a Security Information and Event Management (SIEM) system so that you are alerted to possible intrusions. Which logs should you analyze? The options are: Option A, Data Access Audit Logs. Option B, Policy Denied Audit Logs. Option C, Cloud Identity User Log Events. Option D, Admin Activity Audit Logs.
To arrive at the correct answer, we focus on the keywords: Identity-Aware Proxy (IAP), ingest logs into a Security Information and Event Management (SIEM) system, alerted to possible intrusions.
Correct answer is option A, Data Access Audit Logs.
Why is this correct? A. Data Access Audit Logs record user-driven API calls that read, create, or modify user-provided resource data. IAP logs application access events, including HTTP requests, into data access logs. Analyzing these logs in a SIEM helps identify abnormal access patterns indicative of intrusions. Why are the others incorrect? B. Policy Denied Audit Logs record access denials due to security policies like VPC Service Controls. They do not provide the complete access history to IAP-protected applications necessary for thorough intrusion detection. C. Cloud Identity User Log Events track user lifecycle management and authentication within Google Workspace in Cloud Identity. They do not log the granular application access events managed by Identity-Aware Proxy. Why are the others incorrect? D. Admin Activity Audit Logs record API calls that modify resource configuration or metadata. They do not record user access to IAP-protected applications, which is needed to monitor for intrusions based on access patterns.
Retail customer allows users to upload comments and product reviews. The customer needs to make sure the text does not include sensitive data before the comments or reviews are published. Which Google Cloud service should be used to achieve this? The options are: Option A, Cloud Key Management Service. Option B, Cloud Data Loss Prevention API. Option C, BigQuery. Option D, Web Security Scanner.
To arrive at the correct answer, we focus on the keywords: text does not include sensitive data.
The correct answer is option B, Cloud Data Loss Prevention API.
Why is this correct? B. Cloud Data Loss Prevention API is specifically designed to inspect text and automatically detect, classify, and redact sensitive data such as PII before it is published. Why are the others incorrect? A. Cloud Key Management Service is used for managing cryptographic keys and encrypting data, not for inspecting or filtering text for sensitive information. C. BigQuery is a fully managed enterprise data warehouse for analytics, not a service designed to inspect and redact sensitive data from user-submitted text. D. Web Security Scanner identifies security vulnerabilities in web applications, such as cross-site scripting, but does not scan user-uploaded text for sensitive data.
Your team needs to configure their Google Cloud Platform (GCP) environment so they can centralize the control over networking resources like firewall rules, subnets, and routes. They also have an on-premises environment where resources need access back to the GCP resources through a private VPN connection. The networking resources will need to be controlled by the network security team. Which type of networking design should your team use to meet these requirements? The options are: Option A, Shared VPC Network with a host project and service projects. Option B. Grant compute admin role to the networking team for each engineering project. Option C. VPC peering between all engineering projects using a hub-and-spoke model. Option D. Cloud VPN gateway between all engineering projects using a hub-and-spoke model.
To arrive at the correct answer, we focus on the keywords: centralize the control over networking resources, access back to the GCP resources through a private VPN connection. Networking resources will need to be controlled by the network security team.
The correct answer is option A, shared VPC network with a host project and service projects.
Why is this correct? A. Shared VPC allows you to connect resources from multiple projects to a common virtual private cloud network, centralizing network administration, firewalls, subnets, in a host project while maintaining separation of duties, fulfilling all requirements perfectly. Why are the others incorrect? B. Granting the compute admin role per project does not centralize network management. Each project retains its own isolated VPC network, requiring separate administration and multiple VPN connections to on-premises. C. VPC peering connects networks but does not centralize their administration. Each peered VPC still manages its own firewall rules and subnets independently, violating the requirement for centralized control by the network security team. D. Deploying VPN gateways between projects is a complex, decentralized networking design. It only connects disparate VPCs but does not centralize the administration of firewall rules or subnets under a single network security team.
Your organization has applications that run in multiple clouds. The applications require access to a Google Cloud resource running in your project. You must use short-lived access credentials to maintain security across the clouds. What should you do? The options are: Option A. Create a managed workload identity. Bind an attested identity to the compute engine workload. Option B. Create a service account key. Download the key to each application that requires access to the Google Cloud resource. Option C. Create a workload identity pool with a workload identity provider for each external cloud. Set up a service account and add an IAM binding for impersonation. Option D. Create a VPC firewall rule for ingress traffic with an allow list of the IP ranges of the external cloud applications.
To arrive at the correct answer, we focus on the keywords: applications that run in multiple clouds, access to a Google Cloud resource, short-lived access credentials.
The correct answer is option C, create a workload identity pool with a workload identity provider for each external cloud. Set up a service account and add an IAM binding for impersonation.
Why is this correct? C. Workload Identity Federation allows external workloads to authenticate and impersonate a Google Cloud service account, issuing short-lived credentials without the need to manage service account keys. Why are the others incorrect? A. Managed workload identities and attested identities are typically used for specific Google Cloud resources like Compute Engine, not for applications running in external clouds. B. Service account keys are long-lived credentials, which explicitly violates the requirement to use short-lived access credentials. D. VPC firewall rules control network-level access based on IP addresses but do not provide the required identity-based short-lived access credentials for API access.
Your company has recently enabled Security Command Center at the organization level. You need to implement runtime threat detection for applications running in containers within projects residing in the production folder. Specifically, you need to be notified if additional libraries are loaded or malicious scripts are executed within these running containers. You need to configure Security Command Center to meet this requirement while ensuring findings are visible within Security Command Center. What should you do? The options are: Option A. Create log-based metrics and alerts in cloud logging and cloud monitoring for suspicious container activity within the production folder. Option B. Configure security health analytics within Security Command Center to monitor container runtime vulnerabilities in the production folder. Option C. ensure that the containers in the production folder are running on hosts that are using container-optimized OS. Option D. Enable container threat detection in Security Command Center Premium tier for the projects within the production folder.
To arrive at the correct answer, we focus on the keywords Security Command Center, Runtime Threat Detection for applications running in containers, additional libraries are loaded or malicious scripts are executed, ensuring findings are visible within Security Command Center.
The correct answer is option D. Enable container threat detection in Security Command Center Premium tier for the projects within the production folder.
Why is this correct? D. Container threat detection is a built-in Security Command Center Premium feature specifically designed to monitor container runtime environments. It detects executing malicious scripts and unexpectedly loaded libraries, ensuring all alerts and findings natively surface within the SCC console. Why are the others incorrect? A. Log-based metrics and cloud monitoring alerts do not provide specialized container runtime threat detection, nor do they automatically integrate their findings directly into the Security Command Center dashboard. B. Security Health Analytics focuses on identifying cloud misconfigurations and vulnerabilities in resource configurations, rather than providing runtime threat detection for executing scripts or dynamically loaded libraries inside containers. Why are the others incorrect? C. While using container-optimized OS is a prerequisite for container threat detection, simply ensuring containers run on it does not actively configure or enable the required runtime threat detection capabilities in Security Command Center.
Your organization currently uses a third-party identity provider, IDP, that only requires a username and password for authentication. You need to enforce two-step verification, 2SV, for the superadmins in Cloud Identity. What should you do? The options are: Option A, create an organizational unit, OU, for superadmins, and enable 2SV within Cloud Identity for the OU. Option B, collaborate with the third-party IDP to enable 2SV for superadmins while maintaining the current Cloud Identity configuration. Option C, implement monitoring tools to track the authentication methods used by superadmins in Cloud Identity. Alert on those not using 2SV. Option D, evaluate the 2SV options for superadmins offered by both the third-party IDP and Cloud Identity. Implement the solution that provides the strongest second factor.
To arrive at the correct answer, we focus on the keywords third-party identity provider, IDP, enforce two-step verification, 2SV, superadmins in Cloud Identity.
The correct answer is option A, create an organizational unit, OU, for superadmins, and enable 2SV within Cloud Identity for the OU.
Why is this correct? A. Creating a dedicated organizational unit, OU, for superadmins allows you to enforce two-step verification, 2SV, policies directly in Cloud Identity, aligning with Google's best practice of having superadmins authenticate directly rather than via SSO. Why are the others incorrect? B. Superadmins should not rely on a third-party IDP, SSO, for authentication. They must be able to authenticate directly with Cloud Identity to maintain access if the IDP becomes unavailable. C. Monitoring and alerting on authentication methods is passive and does not fulfill the requirement to proactively enforce two-step verification for superadmins. D. Evaluating options does not fulfill the requirement to enforce 2SV. Furthermore, superadmins must always use Cloud Identity's native 2SV, rather than relying on a third-party IDP, for security and availability.
An organization is moving applications to Google Cloud while maintaining a few mission-critical applications on premises. The organization must transfer the data at a bandwidth of at least 50 gigabits per second. What should they use to ensure secure continued connectivity between sites? The options are: Option A, dedicated interconnect. Option B, cloud router. Option C, cloud VPN. Option D, partner interconnect.
To arrive at the correct answer, we focus on the keywords bandwidth of at least 50 gigabits per second, secure continued connectivity between sites.
The correct answer is option A, dedicated interconnect.
Why is this correct? A. Dedicated interconnect provides direct physical connections to Google's network, offering 10 gigabits per second or 100 gigabits per second capacities. It is specifically recommended for organizations with high bandwidth requirements that exceed 10 gigabits per second, easily meeting the 50 gigabits per second minimum. Why are the others incorrect? B. Cloud Router dynamically exchanges routes between your Google Cloud VPC and on-premises networks using BGP, but it does not provide the physical data plane connectivity or physical bandwidth itself. C. Cloud VPN provides encrypted connections over the public internet, but each tunnel supports a maximum throughput of only 3 gigabits per second, which is entirely insufficient for a 50 gigabits per second bandwidth requirement. Why are the others incorrect? D. Partner interconnect provides connectivity through a third-party service provider and is typically recommended for bandwidth requirements below 10 gigabits per second or when a Google colocation facility cannot be reached directly.